So taking a look at what we've got, 1/5 times the integral of cosine of u du, right? One thing that you should note, right, at this point, the new integral that you get, right, the one after the substitution, that one should be simpler than the one you started with. And if it's not, right, then that's a sign that you picked the wrong u, most likely. And again, there's no shame in that, picking the wrong u, right? But what you need to do is just go back to the beginning, right, and pick another u, try another u, and see if that works, okay? All right, so now we're at the point, we've got an integral that's pretty straightforward, right? And so we just integrated. So we have 1/5, and some function whose derivative is cosine, right, is just sine of u plus some constant c. Okay, so now we've got the integral, but it's in terms of u. What you're going to need to do then is to go back and back substitute, right? We know that u is equal to 5x, so now we're going to switch all the u's back to x's, right? And since u is equal to 5x, we can just put 5x in place of the u. And now we have our antiderivative, right? The same one that we got the other way, and so it's exactly the same. So you might think, well, it seems like quite a few steps to integration by substitution, right? And there is, right? But in some of the more complicated problems, right, this is definitely the way to go. In the simpler problems, maybe the guess and check might be a little bit easier to me, especially as you start to gain more experience working these problems. Okay, just to recap the general steps for integration. Number one, identify the problem as an integration by substitution problem. So this would be similar to the chain rule type problems. We have some basic antiderivative or integral facts, right, that you need to know from the previous section. And the integration by substitution problems would be ones where the inside part basically is more complicated, or ones where the basic facts don't apply. You're going to pick u, right, as to be some part of your integral, and in a second we'll talk about what are some good choices for u and some bad choices for u. The next step is to calculate the du, right, and then make your substitution and adjusting the u and or the du if necessary. And the easier problems, really, it's just the du that you'll have to adjust. In some of the more difficult problems, right, it might be both the u and the du. Step 5 is to integrate, right, and then back substitute, switch back to the original variable. Okay, so that's how the general outline of the steps for integration by substitution. All right, what are some good choices for you? The most, probably usually the best choice for you, although again, not always, you can't say this always works, but the inside parts of the function, right, are probably a good choice for you. That's one to try if there's nothing else obvious in there. Okay, the other thing is parts of the function whose derivative or almost appear or appear as a factor in the integral. So in other words, if you have x cubed or something, and then in the integral you see 3x squared in there somewhere, then that's probably a good sign that u, especially if the x cubed is inside of another function, that you would pick u to be x cubed. And it doesn't have to be exactly 3x squared. That's why I say almost. It could be x squared or 5x squared or 7x squared, where it differs by a constant, right? Because you can adjust your du, and so the constant part of it really doesn't matter that much. If you don't see anything like parts 1 or 2, then the denominators of the function in the integral might be a good choice. So the bottom part, right, of a fraction in there. Exponents of exponential functions. So if you have e to some other function of x in there, that exponent part might be a good part to choose to be u. And then parts of the integral that you don't know how to integrate, but you can take the derivative of. So examples of that would be something like natural log x, right? We haven't talked about how to integrate or the antiderivative of natural log of x, but we do know that the derivative of natural log x is 1 over x, right? It's the same thing for inverse trigonometric functions. For instance, we don't have anything that tells us what the antiderivative or integral of the tan inverse function, right, is, but we do know that the derivative of the inverse tangent function is 1 over 1 plus x squared, right? So those would be good choices for you in the problems there. And as you look through the examples and work through the problems, you'll kind of identify which parts are good choices for you. Some bad choices for you that you should never really make. Number one, u equals x, right? Don't bother wasting your time, right? If you can do this, right, and calculate du to be dx, but then when you replace all the x's with u's, you'll have exactly the same integral that you started with. So that's never really a good choice. And then the other thing is u equal the entire integral, right? If you can set u equal to the entire integral, right, and compute it, and it works out, well, what that means is that you didn't really need to use integration by substitution in the first place. So if you find yourself doing these two things, then you really don't want to do that. All right, and that's about it for integration by substitution. We'll take a look at a few examples of how that goes after this.